Hello everyone. शुभ नववर्ष to everyone. We'll be starting in a while. जल्दी जल्दी से सब लोग अपने दोस्तों को ले आओ. And are you guys excited for the last session of Kate Smashers? I can't see any replies in chat box. How's the Josh? Yes. Hi ma'am. Very high. Good. So hello everyone. It's great to meet you all again with us for the last week of Skate Smashers. I am Shruti Jain from social media team and I welcome every one of you to the last session of Skate Smashers. So, it's week 7 of Skate Smashers. We have been on a long way. How was the journey? Let me know in the comment box, chat box. Okay, I'm getting a lots of replies. Impressive, full packed fun was there. Learned a lot, lots of new concepts. Any more? Conquered my fear, should I say? Of course. Please go ahead. So, as we are in the last week of Kate Smashers, we think it's almost done. But no, it's a lot more. Stay tuned with us for further updates and sessions to learn more. So, now I would like our speaker to continue from here. Over to you, Ronit Bhaiya.
Hey, hello everyone. Wishing you a Shubho Navabarsho to everyone and well wishes to their family and friends. तो आज सब एंजॉय कर रहे हो ना apart from being in the session, guys? Alright. देखो माहौल ऐसा बना रखा है मैंने, ठीक है? वर्चुअल माहौल है बट ठीक है चलता है. Anyways, तो this is the grand finale for Kate Smashers Bootcamp. And yeah, as requested by everyone, here I am to take you through the last session. But it's not the least because we will have upcoming boot camps around few months, and also like we will have in detail deep dives for individual concepts. So yeah, let's talk about the current situation of the boot camp, right? So we had 6 sessions, and we got a really overwhelming response of near about 300 to 400 registrations. Uh, for this, we actually got approximately 500 Discord members. So congrats to the CNH team. And I'm really, really happy to have everyone on board. And the organizing team is also very active very recently. So kudos to them as well. Anyways, without further ado, let's get started. I am on my secondary laptop. I'll just share the screen. Please let me know if you can see it. And also let me know if there's some problems with it. So, okay, is it visible? Okay, I can see it from here as well. I believe it's visible, right? All right. So, let's just go through the sessions what we had recently. The first one being the Linux for cloud natives. And okay, so before getting started with the listing, I would just love to mention that this was done on purpose. This entire thing is actually linked with each other. So if you get started with the first session, and you will end up being in the last session till the end. So there is a process of learning DevOps and getting into the cloud native ecosystem. And I just tried to make it easier for you guys who are novice or who are actually trying to start off their journey with cloud native and DevOps. So this was our initiative so that people can get educated, and I believe that we are growing with that, and we are successfully adding value to your skill set. And if so, then please give me a like or a react or anything that can be possible. All right, all right. So I believe, yeah, this is some emoticons from like Apple. I think. Okay, can you see this? Okay, nice. Anyways, this works. Sometimes it doesn't. So, uh, all right. Akash, do you want to say something? You are. Do you want to say something, Akash? Okay. I think. Can anyone please mute him? I think he's unmuted by mistake. So yeah. Let's deep dive into the topics now. So, beginning with Linux, we have already covered Linux basics, the commands, how the interface works, and how we are actually interacting with the kernel. And the next we had networking. Networking is by far the most important but least bothered concept. Folks genuinely like generally folks actually ignore this topic, but to be very honest, this is very, very important. And then we come to the DevOps practices. This is some real skin in the game concept. So DevOps practices and some basic hands-on for CI/CD pipeline using Jenkins. Then we slowly move towards cloud computing, which was covered by our beloved Nasirul Bhaiya. And then we got to the crux of Docker, which was a long, extensive session of 2 hours or more. And then we got to the basics of Kubernetes. So it was a roller coaster ride for me as well. And then why we are here today? So what we will do is we will just summarize everything, and we will get to know why these concepts are important for cloud native. And we will also have a deep dive into the CNCF landscape at the end. So without further ado, let's get started. Let me have a sip of water. All right, let's do it. Um, so before getting started, I would love to mention that I have no slides for this session or presentation, anything. So what I'll do is I'll go through some hands-ons. This is completely unplanned session, so please don't kill me. Um, I'll just go through notes. I'll go through personalized docs which I created for you guys, and for anyone who is starting out with Cloud Native and want to pursue a KCNA certification, that will be very very helpful. This is also a professional certification, so we don't need every topic to be covered, but still I'll go uh, upar upar se, right? So acha, let's get started with this. I'll just stop sharing and share another tab. Here we go. Meanwhile, I'll just put my phone to silence so that you are not disturbed. Okay, so primarily this note was made while I was completing my KCNA certification. But don't worry, I'll not go very, very deep inside. I'll just cover the important topics and also talk about why cloud native governance and the relevant architecture is important. I'll also go inside some of the Kubernetes hands-on, and also I'll just go inside tools which are actually very, very necessary for cloud native observability and also delivery. Okay, let's get started. Let's go inside this. So I'll go. Okay. Meanwhile, if you want to follow along, you can just have this link. I'll just copy and paste it. Okay. Uh, where is the? Okay, hold on. I can't find the window. Hold on. Okay. Here we go. So here is your doc link. I can actually pin it for you so that you will not get lost. Right? So yeah. Okay. Fine. Now let's share this doc. And yes, I'll just keep getting back to hands-on time to time so that it doesn't get boring. And at the end, I believe we will have a quiz as well. So yeah, let's get into the cloud native architecture first. So what we will be learning is what and how cloud native actually works. Okay, so I'll just give you a short intro about monolithic and microservice architecture. Uh, I'll just give you a short example. I think these topics are already being covered, so I'll just go with very basic knowledge. So, how monolithic architecture work is like there is suppose with a simple example you will be able to grasp it. For example, you are talking about something like Amazon. Okay, now when we are opening the Amazon website, we get to see cart section, we get to see the search bar, we get to see the products listed, right? So what we do is we just go to the like main page, we search for an item, we just get to the add to cart option and we buy our product, right? For example, you want to check out that, hey, I want to see if the review is good for the product, and you get to the review section and you check out the reviews, then you buy the product. If the reviews are good, then only you buy it, right? That's what I do, that's what everyone does. So for example, if Amazon was a monolithic architecture, what would have happened? For example, there's some issue with the review section, there's some issue with the rating section. For example, 4.5 stars, or suppose kuch 4.5 stars are there for a product, but it's showing zero for some reason. And it's not just for that product, it's for every product, like everywhere it's zero. So what Amazon should do is fix that bug, right? So previously, what happened was, what would have happened is like the whole Amazon site is being like paused. Then the bug would have been fixed. Then it would have been reposted or re deployed. in DevOps language. So what would have happened for that? Millions of dollars would have been lost for this particular approach. So your downtime is there. Okay, this is a word which I would focus on. Downtime is there. There's a financial loss. There's a brand identity loss. Okay, if you are a big company like Amazon, there is something known as, you know, naam, right? So you can't play around with it, your brand name, your brand identity. So there are multiple reasons why monolithic architecture is भाड़ में गया, and we get microservice architecture. What microservice architecture does for you is we actually can break one individual service into multiple microservices. Okay, so for example, this one is your review section, this one is your add to cart section, this one is your search bar section. Every particular item is a separate microservice which can communicate with each other. As you can see, these are communicating with each other. Okay, and not necessarily every microservice should communicate with each other. For example, this one and this one are connected, but okay, but this one is not connected to this one for some reason. So it's not necessary that everything should be connected to each other. It's just that according to your own needs, right? So I think you got the basic understanding for the microservice and monolithic architecture and why we need microservice architecture. So let's get to the properties. Of course, the automated process, once you, like, for example, something gets down, you get a better uptime, you just can replicate your particular microservice. That's why automated. Self-healing system, as I already told you. Scalability, then cost efficiency, maintenance ease, inheritance security, and the practical example already I told you, right? So let's not go inside this. I'll just go inside a bit of community and governance, not much, because you are talking about cloud native, right? So there are multiple cloud native projects across cloud native landscape. I'll get to the landscape later on, but these projects are segregated in three types. Okay, first being the sandbox stage, the second being the sorry, yeah, the second being the incubating stage, and the third being the graduation stage. Okay, so what does this mean actually? So if you're talking about sandbox stage, sandbox is really coined as the early stage projects. Okay, whenever we are talking about a new project in CNCF landscape, it is called sandbox stage. Okay, then it gains a maturity, and dhire dhire it gets to the incubating stage. Okay, and sorry, so it dhire dhire it gets to the incubating stage, and these criterias are increasing time to time. Whenever you are reaching some level, you are added with some more criteria so that you can reach the next level. So this is how it happens. This is a bit talk about the community and governance for the CNCF projects. Now I'll get to the container orchestration. All right. So you already know about Docker, right? I won't go into what containers are and all. So let's get straight to the point. Let's have some hands-on. You guys ready with the hands-on? I think you guys already know about this. I'll just go inside hands-on so that it kills less time for you guys, and it can be more interactive as well. What do you think? All right. All right. All right. All right. Okay. Okay. So what we will do is we will run containers, and yeah, let's do one thing. Let me just open the terminal, stop sharing. Okay. Mm, if for some reason it's not allowing me to share any other applications, if so, then I have to switch to my this laptop. Okay, let me try with this one. All right. Mm, okay. Just a second. Is my terminal visible? Alright, I have to clear this up. I was doing some work previously, so uh, let me create a fresh window and share that one. Okay, all right, this works. Okay, so what we will do is we will have the Docker daemon on first. I'll just make sure if the Docker daemon is on. Uh, check. Okay, I think I can just share the entire screen. That will be best. Okay, so the Docker engine is starting. Okay, so the Docker engine is up. I have few images in my locals. What I'll do is I'll just pull up a simple image of Nginx. Okay. So what should I run is Docker run interactive terminal and Nginx, for example, and it will search for Nginx. Okay. I think I did have a Nginx image over here. Okay. I'm getting a container. Okay. This container is running on my local system, right? If you can see in this particular Nginx is being used. The latest Nginx is being used because I am using this image to create my container. Okay. I think up to this, everything is clear for you guys if you have attended the previous sessions. If not, please let me know over the chat, please. You guys have the idea about Docker and the basic commands, how Docker works and all, right? I can just show you real quick if anything is running or not. I've just closed the particular instance from here, so it's showing that it's not running. If I run the same using detached mode, then what will it show? I can see that this particular image is working, right? This image is working and it was started 2 seconds ago and it gives us a lucrative name for some reason. So yeah, um, just want to confirm if this is already known to you or not. Otherwise, I can get to the main part. I'll move slowly towards Kubernetes to be very specific. And also, I might touch upon some of the GCP as well using Google Kubernetes Engine. All right, all right, all right, all right. Then I think we are good to go with, okay, the window. Cloud.google.com. What I'll do is I'll just create a VM real quick. Okay. Uh, can you guys give me a name for my instance? Anyone from here? Just give me a name for my instance. Anything. Anything works. Okay, Navabarsha works for me. Okay, fine. Chalo. Copied and pasted. I'll just put my region for Asia South 1, that is Mumbai. C looks good. Uh, into, okay, this works. This works as well. All right. 2 vCPUs and 8 GB memory, standard provisioning, won't deploy separate containers. This looks good, right? Allow HTTPS. Yes, I'll allow. Okay. So what I'm trying to achieve from this session is that I'll just give you quick touch upons from the previous sessions so that you guys can recollect everything what happened, right? So meanwhile, I'll just create a Kubernetes cluster on GKE as well. Now, while this is being spun up, I'll just go inside this and create a Kubernetes cluster. I'll configure this on my own. Thank you. All right. Let's name it Novoborsho cluster. No, Novoborsho cluster. Yeah. Okay. I want my Novoborsho to happen in India itself. So let's call Asia South. One, yeah, works. All right. Release channel should be recommended 1.27. Okay, fine. Default pool. Okay, number of nodes. I just want one for now. Okay. Mm, okay, these looks good. I'll just have full access to the cloud APIs, and the rest looks good to me. I'll just create the cluster for now. Okay, just create the cluster. And let's check back. Okay, while this is being created, I think, yeah. So I have already created this request to create a cluster, and meanwhile, I'll just get back to the compute engine and SSH into the previous one. I believe that it's done. The VM instance is ready. Yes, it's ready. Let's SSH into this. All right. Running containers is clear. I'll also show how to like work around with terminal over VMs. Then I'll slowly move towards Kubernetes. Okay. So Ronit, that Navabarsha is ready. If I just load it up, okay. So you can see, I can just go for a sudo su so that I don't need to do this sudo thing every time, right? And let's make some apt get update. Okay, so let's uh, show you how we can actually install Docker from scratch. Okay, so what we can do is we can just get to the Docker's documentation. Okay, here you will have how to install Docker. Okay, hold on. I think this one should have it. Linux. Hmm, it doesn't. Okay, okay. So this tells me to do a lot of stuff. But what I'll do is I'll just have, okay, let's have the GNOME terminal first. Then we will, okay, not this one, not this one, not this one, this one. We SSH'd into this, yeah. So what I'll do is I'll just install this and I'll just install this one. Just checking with the latest version. Install Docker DB package. Okay, let's install Docker using apt. Okay, this one works. Hmm, all right. Meanwhile, let this prerequisite repository be installed. Inform progress. All right. So now I'll just go for this one. Okay. 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 Now I have to set up the Docker's apt rep. Okay, this thing done. And I'll slowly install the final package for Docker. Okay. Um, okay. So is it done? Let me check. Uh, nope, it's not done yet. Okay, this couldn't find. Something is wrong with this documentation. All right. Ah, documentation not updated. Very good. Okay. Mm, meanwhile, I can just jump into the GK part. That would be more better. Okay. The Novoverso cluster is done, I believe, isn't it? Okay, it's getting the health check, so it will be done in a couple of moments. And then what we will do is we will just check with the credentials for this cluster so that we can actually access this from our local CLI from here itself. And for that, we need to have this G Cloud CLI on your local machine. So make sure that you have it installed already. Then only you can access this cluster. Okay. And installing G Cloud is not a very tedious job. I'll just show you G Cloud CLI installation. I can share you the doc. Install the G Cloud CLI. Okay, this will help you with this. Okay, it won't take much time to install G Cloud CLI. I'll just paste the link over here. Okay. All right. Let me check if that is done meanwhile. This one. Okay, the cluster is up and running. Now we can actually SSH into it. Okay, so to connect with this, I'll just go and copy this connect command. This just gets the credentials and updates your local kube config for that. Okay. Fetching cluster endpoints or data kube config entry generated. Now I can actually use my cluster. So if I do kubectl get pods dash a, I should get, yeah, I'm getting these pods which are actually created by default by Google Kubernetes engine, right? These are not created by me, these are created by Google itself, as they are managing the cluster for me. Because if I can explain it in a better sense, we have two kinds of cluster. One is self-managed and one is your cloud provider managed. So AWS has its EKS, okay. Google has GKE, and so on and so forth, right? So for that, we are using GKE for here for this demonstration. And now this is being totally controlled by Google itself, right? Now, what I'll do is I'll just take you to the documentation real quick so that we can jump from where we got here. Okay. Okay. Yeah, setting up the Kubernetes. Okay. Now, considering that you don't have anything set up on your local machine, what you will do, and this might be the case for yourself. So, why did I spin up that particular machine? Okay. So, considering that you don't have Kubernetes installed, considering that you don't have Docker installed, that's why I set up that machine. And if I consider that you have a GKE cluster on your Google Cloud, so both of the topics will be covered simultaneously. Now, let's get to the cluster first, because we have the cluster ready already. Then we will slowly move towards the installation part. Now, what we can do is, okay, let's just get to that window. Uh, all right, I think I can access it from here. Yeah. So, so if I get namespaces, I have three of them. Okay, there's a default one, GMP is, yep. So what I'll do is I'll just create a sample application YAML, which I have already in my local system, if I'm not wrong. Yeah. Okay. So let's cd into that document slash YAML, and I'll just list those, and I'll just have a demo for running a particular deployment over here. Right. Let's open with VS Code. And please let me know if I'm getting fast, because I'm considering that you are already aware of these topics from the previous sessions. In case I'm going fast or missing out any of the concepts, please let me know so that I can uh, clear the doubt. Yeah? All right. What I'll do is I'll just create an application that will simply, okay, so that will simply do one thing for me. That is, I'll not keep any resource limitations. I'll just Nginx latest. I'll just use this particular image for that. Okay. And let's rename it as Nginx. App label should be Nginx. Anything relevant will be named as Nginx. Okay. Okay. Now, okay, my bad. And I want to have 5 such copies of the same application. I can have it, right? So Let's run this. Okay, let's see if it works. If it doesn't, we will come back to this and make changes, right? So I'll just command save, and do what I'll do is I'll just kubectl apply dash if, and this is a flag, and the file name, which is demo.yaml, same file. Okay, let's try if this works. Okay, it's created, it says. Let's see if it is created. Let's get the pods. Okay, it's running. So it's running in the default namespace, right? Can you see the copies here? These are simultaneously running, and it's being started 10 seconds ago. As I said, you can see the specification. I just said that there will be 5 such replicas, and we can see 5 such replicas over here. Now, in case, for example, I was talking about that example, right? Where I mentioned that your review section went down for some reason. So what will happen, right? So what I'll do is I'll purposefully delete this pod. I'll just purposefully delete this pod. But what I'll consider is that I just hired a new intern in my company, and he messed up with the files, and he by mistake just deleted this deployment. तो क्या होगा? Let's do it. Kubectl delete pods, enter. Pod is be deleted. So what should happen? I just want some answers from the audience here. What should happen? What do you think that पहले 5 deployments थे? I mean, five. There were 5 pods. Now I deleted one. So how many should be there on production? How many? Answers in the chat box, please. I want some interaction over here. Okay, Aniket said 4. Rest 4. Okay, the rest. एक और आंसर चाहिए मुझे. अच्छा, सभी 4 बोल रहे हैं. Let's check it out. Let's check kubectl get pods a. Okay, is it 4? 1, 2, 3, 4, and 5. That's strange. That's strange. How? How? Let's check. See the age over here. All the pods are 2 minutes, are spun up 2 minutes early, but the only one which was killed regenerated itself, and it says that 51 seconds ago it got here. Getting my point, guys. This is the power of Kubernetes. This is the power of deployments actually. Whenever we see that this type of fault tolerance may come into the picture, like suppose this particular pod or deployment like went down for some reason, but it can regenerate, it can fill that void, and it will give you 0 downtime. This is the power of Kubernetes and cloud native. Got it? I think this makes more sense rather than just showing you documentations. Interesting, folks. All right, all right, all right, all right. Just let me know if you guys are feeling interested. All right, all right. Now, what I'll do is I'll just check if I have more traffic. For example, I have more traffic. Okay. Uh, पहले we had one pods for individual one user. For example, it's just for the sake of example, it can handle more, but for the simplicity, we are considering that one pod can handle one user. Okay. Initially we had 5 customers. There are 5 pods, everyone was happy. Now you told that, hey, this shop is very nice, they give good discounts, you should also uh, buy from here. Then what will happen? Customers will increase, pods be like, yeah. So customers will increase, right? So what should we do? We should scale, right? How will we scale? We can have dynamic scaling. And for now, for the simplicity of like describing and showing, what I'll do is I'll just show you how we can scale and not while not disturbing the existing deployments. Let's see. What I'll do is kubectl scale replicas equals to, let's suppose I want 8. My demand has went from 5 to 8. I got 3 new customers, so 8. Okay. And I will mention the name of the deployment slash nginx, right? Nginx. What should happen? Tell me. It says that it's scaled. How many pods should I get now? How many? Shaumadip says 8. Yes. I don't know who Proton is, but you are actually correct. Like the existing 5 will be remaining as it is, but it will generate 3 more pods. Let's see if it has happened or not. All right, here we go. We have 8 different pods and 3 new pods are being generated as Proton said, right? I'll consider his name as Proton only. So we are having 3 new pods and we aren't disturbing the existing pods as well. You can see the existing pods are always there. The 5 pods are there, but we just scaled up from 5 to 8. Now, suppose I am like that seller, okay, is selling rotten goods. Now, whenever you get more like demand, right, the supply also should get more, right? So, okay. So, what will happen? For example, you had like strength for 5 customers at a time, but now you have a strength of 8, right? But suddenly you start giving them low quality material. Now, what will happen? The customers will go away, right? Your customers will be decreased to, for example, 3. Okay, maybe 2. Okay, let's consider 2 as the worst case scenario. You will be perished. Okay, like 8 from 8 to 2. Okay, so is there any mechanism, Ronit, to scale it down from 8 to 2? Is it? What do you think? Is it possible, guys? Is it possible? Any idea? If possible, how possible? How I would tell, but if just tell me if it's possible or not at all. Curious to know if you have any idea. Probably yes. Rishabh says probably yes. Yes, I guess. Maybe. Who knows? Let's try it out. Okay, let's try it out with the same thing, the same command. What I'll do is I'll just change this number to 3 or 2 maybe. That's true. Let's try it out. It says that it's scaled. So what should happen right now? What are your guesses? What is the number of pods right now? Okay, Ranadev says that it's 10. Okay, so your analogy is that we had 8 and we will have 2 more resulting this. Okay, Shamili said that we will be reduced to 2 points. Okay, let's see who is correct. We are actually reduced to 2 pods. Shamili is the winner over here. So this scale command works both ways, be it increasing the workload, be it decreasing the workload. Right? Uh, Huge shout out to Shamili for your answer. You are correct. So yeah, this is how scalability and everything works. Now, what I'll show you is creating a namespace. Okay. So how namespace works? Namespace is nothing but a bifurcation for your Kubernetes cluster. Let's suppose a virtual cluster for your Kubernetes environment. Let's create one. Let's do it as kubectl create namespace. Give me a name for a namespace, please. Okay, so your question is how to know when it will increase or decrease. Now, this has some quotas. Okay, like whenever we are going above some resource limits, these are being increased dynamically. What I actually mentioned over here was just the idea about the scaling process, but not how it's done in real world. Okay, so when it happens in real world, we have dynamic scaling. Okay, after looking into the resources being consumed, we have that. Okay, k8's Borsho. Okay, let's have k8's Borsho. Fine. K8's Borsho as a namespace. Namespace is being created, it says. Let's check it out. kubectl get namespaces. You can write ns in, you can write namespaces as well, you can write ns as well, both works. So it shows me Kate's Borsho active 17 seconds ago. So it's been created, right? Now, if I check, okay, if I just type in this command, kubectl get pods, let's specify the namespace, Kate's Borsho. Okay, now tell me, how many pods will I see right now if I click on enter? Shomadip says 0. Okay, everyone is getting the idea then. I'm happy. We'll have no resources. Cause why? Can anyone say why it's 0 over chat? Anyone? Why we are getting 0? We haven't connected them. The namespace was just created. Partially correct. It's just created now. Okay. Let's clear the confusion. I have just created the namespace. That's a correct thing, but it's not the correct answer overall. I haven't introduced any deployment or any pod in that specific namespace. Whenever I deployed any application, it was done on default namespace, not a namespace which I have specified. Now what I'll do is I'll actually deploy in that particular namespace. Let's see how I can do it. kubectl apply dash f demo. Then I'll just mention the namespace over here. It's Bosch. Now tell me, will it allow me to create deployments over here? What do you think? Will it? I do think it will. Let's try it out. Okay, it says that deployments.apps./nginx has been created. Now, if I check kubectl get pods, it shows me these two, which are being created 14 minutes ago. Then why does it say that this Nginx deployment has been created? I can't see them. It says it's created, but I can't see them. Where have they gone? This resides the default namespace, right? But I have created this right now. So it should have been listed over here, right? And according to my specification, it should create 5 such replicas. But I can see the two which are being created in the previous namespace. Those are the previous pods, exactly. These are the previous pods. So where have the new pods went? Like, where is it? Any ideas? It says it's created, but I can't see them. Exactly. I have to mention the namespace for that. Now what I'll do is I'll get pods and also mention the namespace. Ta-da! We have them all. It was just hiding behind the bush. But now, if I do another thing, that is kubectl get pods dash dash all namespaces, what will what will it do? It will list every deployment containing in any namespace possible. Let's do it. See, there are many namespaces which are created by Kubernetes by default, like kube systems, GMP systems. Okay, this is another thing that is being created by Google. This is being created by Google. This is created by us, Kates Warshaw, and the default one, right? So we have a total of 7 Nginx pods right now, but two of them are in the default namespace, and 5 of them are in the Kates Warshaw namespace, the different namespace, right? So can this one communicate with this one? What do you think? Can this particular namespace communicate with this particular? Sorry, my bad. Can this particular pod communicate with this particular pod? You can Google an answer. No worries. I won't grab your neck if you Google it. Developers are meant to be the best Googlers on earth, right? I Google a lot. Whenever I get stuck, I Google. I use ChatGPT. I never copy and paste ChatGPT code, but at least I can take help from there. Okay, let's ask Google. Okay, let's ask Google for this. Let's see what does he say. Can a pod in default namespace can can a pod in is will be able to communicate with a pod in different namespace. By default, pods can communicate with each other by their IP addresses regardless of the namespace they are in. What the point? Cause these particular pods have their separate IP addresses. Now, how will I know that? Ronit, you just told that they have an IP address. Why would I believe you, in fact? Right? I will show you. Let's pick this one, and I'll do is kubectl describe pods. Not found. Okay. Okay, I think I have to mention the namespace. My bad. Okay, this pod. Now it should work. Yeah, here it is. Now you can have the entire list of like details relevant to that pod. And if you search closely, you will find the IP address, my dear friend. This is the IP address through which that particular pod can connect to different pods who have some different IP address. For example, let's take some different pod. Okay, we have taken this pod from the Kate's Borsche namespace. Now let's take a pod from this namespace. Okay, let's do kubectl describe everything, and I'll just remove this part, and I'll paste the new pod name. Okay, okay. Now you can see that it also carries an IP address. Okay, but if you notice closely, these two IP addresses are different. This is 10.116.0.21, but this was 10.116.0.28. Get the difference? We do get the difference, right? So these IP addresses are unique. Every pod carries a different IP address, and this is how they communicate with each other. Then you can tell me, then what's the point of namespace? If they can communicate, then what's the point of namespace? It's just for the ease of management. For example, you are giving a particular permission to a particular namespace. Okay, it will handle that. Or you are actually trying to install a particular operator. Maybe you are trying to install a GPU on your Kubernetes cluster. You can actually install NVIDIA GPU operator for that, right? For that, we need a separate namespace so that it is kept at a separate position and it's not disturbed. Just for the ease of management, we need namespaces. Definitely, we need them. All right. Okay, so I think this is pretty much clear. I'm sorry for the random coughs. I'm like, if I was very sick till yesterday, I'm still sick, but it's better. Any questions till now, guys? Is it getting boring by any case? If it is, then I can switch topic. How? I can get back to this one. That is my compute engine. I have to SSH into it again. What I'll do is I'll set up Kubernetes from scratch over here. I have a doc for that. I have mentioned those commands so that I can use it quickly. Commands. Okay. I have it with me, so won't be a problem. Mm, authorize. Thanks, Shamili. I believe everyone is getting what I'm trying to actually say because I'm just trying to summarize it up for everyone so that you get the essence of Kate Smashers. All right. So now you already saw that how K8s works or how Kubernetes can make your life easy, right? But I'll also need to show you like if you don't have Kubernetes on your local machine, like this one. Okay, this is just a machine with nothing in it. So how can I use Kubernetes on this machine? I need to install Docker, Kubernetes, everything. Like there are multiple stuffs. So what I'll do is I'll just go inside this file. I just install from here slowly. Okay. What I'll do is I'll just make it a full screen so that it's visible to all. Okay. And If someone wants to follow along with me, I'll just drop these commands. Okay, so I can drop these commands from here. You don't need helm. You just need up till this QCTL. The rest is irrelevant for you. All right. I'll just paste it. If someone wants to install Docker and Kubernetes in your environment, then this is it. You don't need anything else. All right. Okay, I'll just copy it from here only so that you can, you know that I'm not cheating. This is what it is. Okay, this is not getting copied for some reason. Okay, it's done. Okay, then I'll create a new group named Docker. Created one. Okay, works. Now I'll do for something like this so that everything is done. I think I can use it at once. Let's see. Okay, kubectl says it's okay. Okay, I have kubectl installed. Now, does it guarantee that I can use a Kubernetes cluster over here? Doesn't, right? Because, okay, let's see if I have Docker over here as well. Because, yeah, I have Docker over here as well. So it's pretty much easy to install Docker and Kubernetes. You just need these commands. You can just copy it from here and store it somewhere so that you don't face any issues while installing on your Linux systems. And it's particularly for Linux and Unix based systems, right? So please make sure that you have subsystem, otherwise it will crash or it will fail. Right. Let's try to get some pods from here. It says that there's nothing. The API can't hit this particular address. Why? Because we don't have any cluster over here. Now, how to create a cluster? For that, we need something known as Minikube. Now I want to install Minikube in Linux. Minikube install Ubuntu. Minikube, okay. I have the Kubernetes environment. I have the kubectl, everything is over there. Now I just need to copy this and simply paste it there. If I do Minikube start, okay, sorry, my bad. I just typo. Does it say that it's not working? Sudo install. Okay, I think I haven't installed it yet, but check. Should start. Exec format error. Cannot execute binary file. Okay, let's see. Oh, this is for macOS. My bad. I forgot to check on this. Sorry, guys. Stable binary download. Yeah. Okay, now this should work. I just copied the wrong file. My mistake. Um, cannot install. No such file or directory. Okay. Yeah, just yeah, this should work. If this works, then I'll just paste it in the chat box. Okay, let's try to Minikube start. Okay, it does work finally. So I'll just uh, put this over here so that you can actually use Minikube in your local system and enjoy Kubernetes. All right, let's wait for this to start off. Till then, I'll just take. Okay, didn't understand the error you got. Okay, that was nothing actually. By mistake, I just copied the Mac OS binaries instead of Linux binaries because this is a VM, right? This is a Linux VM. I have to install Linux binaries on this, not macOS binaries. I just copied the macOS binaries by mistake, so it was not functioning. That's all. Nothing serious. Yeah. Now it has downloaded everything that was required. Now it's creating a environment so that we can actually run our cluster with two CPUs and 2 gigs of RAM, preparing the environment, generating certificates and keys. Okay. Folks often tell me that it's very, very difficult to get hold of a Kubernetes cluster. Please show it to them and tell them that it's totally feasible. Yeah, hey, we have the Kubernetes cluster up and running using Minikube. So, right, this is the only command you need to have Kubernetes cluster running on your setup. That's it. That's basically it. You need Docker, you need the kubectl CLI, and you need to have the Minikube. And you have everything on your chat box. And if you need it separately on a doc, let me know. I'll share it separately as well. But this is what it is, right? Nothing rocket science, nothing. Okay, it's that easy. And if you want to create the same deployment, like if you can actually say that Ronit, I don't believe you. Okay, you can't run that particular deployment on this cluster. That cluster was managed by Google. Now you are managing the cluster. It's not possible to deploy apps and scale it and do this and that. So let's try it out. Okay. What I'll do is I'll just create a sample application YAML that is via app.yaml. Let's say. Okay. Now I'll just paste that particular code. Nothing much I'll do from here. I'll just copy this and paste it. Okay. I'll just save. Now I have this file named app.yaml. What I'll do is I'll just do the same thing which I did previously, kubectl apply dash f and the YAML name application.yaml. Should it work? Let's work out. Okay, it says that the deployment is created. Now what I'll do is I'll just check the pods. Now it's creating. It's still in the creating state. Some of them are in the running state. Running, running, done. It was that easy. So it doesn't matter if your Kubernetes cluster is being managed by Google or it's managed by yourself, you by yourself. So it doesn't matter. Minikube is a good solution for your local deployments, handling and playing around with Kubernetes. But if you are trying to go for production level clusters, you should try out kubeadm. Okay. And also, there's another self-managed Kubernetes service that is known as RKE, produced by Rancher Labs. You can check it out as well. It's fairly complex, so I won't suggest you that right now. But you can play around with Minikube as you already have the commands. Is it clear, guys? And please let me know if it's interesting. I don't want to give you a grumpy chuckle and make your day worse. Already, I've made your day worse by inviting you to this talk in this festive season. But I just want to hear back if it's going okay or not. Guys, please. Okay, Rishabh says it's been quite interesting. All right. Are you able to grasp the concept? Like, is it understandable, or am I going too fast, or am I skipping topics? Please let me know. All right. Maybe this will also be some random YouTube tutorial someday. So can't judge. Insightful, pace is just right. All right. So you now have the idea of having a Kubernetes cluster on GKE on a managed Kubernetes service. You have idea how to install Kubernetes, kubectl, Docker on a fresh machine and get started with Kubernetes. So we are good to go with the rest of the session, right? Okay, so what I'll do is I'll just get back to that documentation which I wrote. Hold on. Yeah, this one. So now you have learned how to set up Kubernetes. You know what is Minikube. I also like you can also try out kind and microkits, but Minikube is the easiest one, ideal for running one single node Kubernetes cluster. Right. So Kubernetes API. Okay, so everything I'm doing with kubectl, like if I'm writing kubectl over here and writing some commands and it's returning something, it's actually communicating with the Kubernetes API. Okay, so this is how it works. These are the pods, and this is the human or the user, which I am for here. So API server is there active. Chaukanna. Okay, we are requesting something, it is providing it for us. It's just basic API concept, nothing rocket science. Okay, and this is something which is RESTful, just like normal APIs, post, get, requests, and all. Okay. Running containers in Kubernetes, I have already shown it to you how pods work, everything. Okay, without any blabbering or just randomly reading docs. I just showed it to you so that it's really clear and concise for you. These are the concepts you can actually um, get your head into after this session. You can read my docs, but I'll not go inside this right now. Okay, this is traditional and Kubernetes scheduling. Let's not talk about it. Okay, let's talk about the common misconception. So, folks think that whenever we are talking about scaling, it's very much involved with artificial intelligence. Folks think that, hey, there's some AI model being trained so that it can actually analyze what is the particular workload right now, and it can scale the application. No, it doesn't happen like that. It's just a resource quota. It's just a bare minimum resource allocation, after which it will scale up or scale down. Okay, it's just a threshold value, nothing else, nothing relevant to AI. Okay, and it's user defined requirements. It's up to the user to specify the application's requirements. Kubernetes uses this information to filter and select the most appropriate node. So what happens is whenever we request a deployment, there can be multiple nodes. What I showed recently was single node applications, but whenever we are talking about multi-node, it actually depends on the tags. There are multiple things involved over here. I won't go inside that. It can get a bit complex, but yeah, we actually as human beings program it in a such a way that this particular pod or deployment get into such particular node so that everything is managed properly. Okay, it's not done by AI, or it's not decided by Kubernetes. It's decided by us only with specific configurations, right? Okay, let's understand Kubernetes objects. Um, okay, so I have talked about namespaces. I have also mentioned about this. I'll just go inside this once. So when I was talking about this particular YAML file, you already have seen this in real time, that I wrote a YAML file which had this type of text, which can be gibberish for now, but I just mentioned it real quick how it works. So API server version, okay, this is for the apps slash v1. It never changes really, so it will be the constant one. Kind is something that is actually mentioning if it's a deployment. It can be a replica set as well. It can be a daemon set. There are multiple kinds of processes. Okay, so you can actually specify this according to your own needs. Metadata is nothing but information. It's information stored in key value pair format. So if it's name, it's Nginx deployment. I can actually name it as Ronit Banerjee. I can actually name it as Shubhanova. So I can like I can actually name it as anything. Okay, it's up to me how I'll name it. And spec. The spec is nothing but how this will function, what will be the like allocated resources to it, how many replicas will be there. As I mentioned, the replica concept over here, if you check, it's under spec. Okay, there are many things like templates, selectors. Okay, which I'll not talk about right now, but also the spec also has a subspec of the container, which is Nginx for here. And also it can mention the port where this application will be exposed to the public interface, right? So this is how this particular YAML file works, right? Let's go ahead with this. Using kubectl, you are already aware how kubectl works. Won't mention much. Okay, I think. Okay, so someone can ask me, hey, this terminal looks very like scary for me. So what should I do? You can use Kubernetes dashboard. You can use Lens. Okay. You can use K9s. You can use VMware Tanzu. Okay. So these are some of the popular GUI applications through which you can actually manage Kubernetes cluster. I believe I have Lens installed on my system, so I can just show you Lens how it looks and feels like. If it's set up, I'll just show you. Okay, it's working. I believe I can show it to you how it looks. I just forgot about this, that it exists in my machine because I primarily work on terminal. Anyways, good for the demonstration purpose. I'm happy that I have installed it earlier. Aditya is experienced over here. Thanks for joining, Aditya. So this is Lens. My computer might be a bit slow. All right. So what I'll do is I'll just go inside catalogs. If you see the cluster, I can actually open this particular cluster over here. These are some of the clusters which are here. For now, I do have something that is connected. I believe this one. Now, what's the cluster? Let's try to connect. All right. I think it's connected. If I check the pods, see, I can see everything. In fact, the Nginx deployments I made in the recent past, I can see the deployment as a whole. I have the deployment in this Novoborsho, Kate's Borsho namespace. I have it in the default namespace. The rest of the default deployments, I don't have any daemon sets. Okay, I do have, but these are not active, I believe. Anyways, so if you ask about daemon sets, this is nothing but pods which should be available for every node. Okay, won't get inside this particular thing more because this can get a bit tricky for beginners, but if you are interested you can check it on the docs. Everything is mentioned over there. Okay, there are these are the particular types of this. Okay, if you see this particular kind, you see kind deployment over here. There are multiple kinds such as daemon sets, stateful sets, replica sets, jobs, cron jobs. Everything is relevant to this particular type. Okay, the kind which I was talking about. Now, I'll not get much into this. If you just are interested in how this works, you can actually like explore it. Okay, but I won't go deep inside Lens right now because I'm also not very much of an advanced user of limbs. So yeah. Okay. Now I'll quickly go get back to the docs. Okay. You already have the idea about the pods concept. Okay. So, I think I missed on this one. So, init container. So, any idea about init containers? Anyone? If not, I'll just mention it in a nutshell. Init containers are nothing but containers which are spun up just to make sure the main container is all right. Okay. For example, um, I think that will be the best example. Have you ever used boat for traveling? Boat now, nauka. Have you seen boats operating while crossing rivers, right? So what happens is whenever everyone who wants to travel using the boat gets on the boat, and there's one guy who actually sails the boat, right? So what happens is when like before starting the boat, there must be someone at the end of like at some point where he or she just pushes the boat with his foot so that it gets into the water. He tries to push the boat towards water so that it gets a head start, right? To get some motion, that particular person pushes the boat. So this is what init container does. Init container just functions as that pusher. After this push is done, this stops and this vanishes. Okay, and the main container comes into the picture. Okay, and everything happens within a pod. Now, someone can ask how many containers can a pod have? Is it one? No, the answer is not. It can have multiple containers within a single pod. Okay, all right. So, pod life cycle, pending running. Okay, I won't go inside this. Kubernetes objects. Okay, replica sets, deployment, stateful set, daemon set, jobs, cron jobs. You can just go inside these details from this talk. I can share this again with you guys so that the ones who joined late can also refer to this. Uh, yeah, all right. Okay, network objects, cluster IP. Okay, now apart from this, we have some services as well. Now, what is services? Services are nothing but a different kind of object that lets your deployment to be accessible from the outside world, apart from the cluster itself. I think that's too much gyan. Let's try out a deployment. And like, I mean, let's try out a service. So how we can do it? Let's let's do one thing. Do I have that active? Yes, I have it active. Let's clear it out. What I'll do is, mm, I just see kubectl get SVC. SVC stands for services for Kubernetes. Okay. It says that I have that cluster IP of Kubernetes itself with this port. Okay. Now, if you want to like access this particular dashboard, how can you access this? Using service. And we don't have that right now. If you check Kubernetes as kubectl get services dash A for all the pods, we'll have two of them. One is the kube system and is this one. Only this one is functioning, but this is limited to the Kubernetes cluster itself. It has no external IP. The external IP for this is the same for the VM. Okay, if I consider the VM over here, this VM has some IP address This external IP you can, this is the IP for this VM. Navabarsho has the external IP of this one. Okay, 3400 172 44. Okay, if I just go inside this, nothing will happen, right? It will show me nothing. If I just search for it, nothing will happen. Now, if I try to access port 80, will it work? No, it won't. Because the services are not running right now. So what should we do? For that, we need a service known as node port or cluster IP. Anything works. Okay. There's cluster IP is here, which is responsible for controlling the services within the cluster. But I want to get access through the web so that everyone can access this. So what I'll do is create a node port, extends the cluster IP by opening a specific port on all nodes IP, allowing external traffic to reach the service. Getting the point, right? So what I'll do is I'll create a node port for this. And for that, I have a separate command written somewhere. Because if I try to find that, it will take me more time. So I'll just move to this one directly. I have it written over here somewhere. Okay. I have this expose thing. How can I do it? Now what I'll do is I'll just get to the terminal. I think this one. Yes. I have to change the ports. Target port will be 80 and 80. The type will be node port. And the deployment, the expose, what we'll do is expose uh, this one, cluster IP. So we will have this as, I think I have to check the service over here. Okay, expose. Okay, I think I need to check something else before this. I need to check if it has a specific pod identity. Let's see. PCD pod. Okay, fine. All right. Let's try to use this. Let's try to use this command. Let's see if it works. Type node port expose deployment to Kubernetes. Selector flag. Sorry. Okay. Hold on. Okay, this is not found. Okay, let's try it somehow else. What I'll do is I'll just Google it from here, like how to expose Kubernetes dashboard using Notepad. Okay, let's see what it's telling me. I'll after this is done, I'll see something like this. Okay, so it says that I have it. Okay, I think I have to change something in the services itself, not here. Let's do one thing. What I can do is let's forget it for now, because this may create more complications and I don't want to confuse any one of you. All right. But I think you got the concept of services, right? How we are trying to get this particular port And let me just check if this port is actually working. 443. It says that it should work. Let's test it out. Um, Copy this, paste it over here, and 443. Does it work? Doesn't, because this is just internally allocated to the Kubernetes cluster. It's not being exposed to the outside world. That's why it's not working. Okay. So this is the concept of services. Okay. If I go and set up this service, it will actually consume a lot of time. So let's not go inside that right now. All right. Let's get to the next thing. I think you got the idea behind services, right? If I'm not wrong, please let me know. Guys, is services clear to you? How services is working? It's nothing but like it's exposing your particular deployment to the rest of the world. First, that's it. Okay. And why the Kubernetes dashboard was not available? Because it's just allocated to that particular like Kubernetes cluster. It's not exposed to the outside world. There and why I avoided showing it to you right now, because we have to do two things. Firstly, we have to write a separate YAML for this particular service, and also I have to make sure that the firewall policies are again recreated. So that can be a bit tricky for now. So I'm skipping that, right? Okay. If you want to explore more, you can. Okay. All right. Uh, let's talk about volumes and storages. So Kubernetes comes with a concept of persistent volume so that you can actually save your data on your volume, right? Like, for example, this actually works here, it works like your pen drive to your container. For example, you are spinning up a container and you're having a microservice which can actually serve your database. Okay. Now you just thought that, hey, let's turn off the container, and you turned it off. Now you are restarting the container and you saw that, hey, the data is gone. So how to counter that? For that, we have volumes so that it can save your data and persist it, and it can actually get attached whenever you are regenerating that particular deployment or pod or container, anything you may like to mention, right? So this is how it works. If you see, there's a mount path and it carries a name to it, and whenever you're deleting it and regenerating it, it gets connected to the new pod or the new yep, it's the pod here. So I'll talk about pod. So whenever you are regenerating the pod, it gets connected and your data is saved, and your data can be reused, which was there previously on the previous pod, right? So this is how this PV works and all. So allows the pod to consume PVs, everything. Okay, so there's two concepts. One is PV itself, and there's one is persistent volume claims. So what PVC does is it actually grants the permission and claims the volume for you, and PV is the storage unit itself, right? And this is some like example which actually has some reference of AWS EBS volumes. So you can check it out. You can actually copy this and paste it in your terminal and apply it, and you will have your own PVC for your testing purpose. Now, what is CSI? CSI is nothing but the storage interface. This actually serves as the network for managing the container and its storages. Okay, so for now, uh, it has Rook. Rook is a Kubernetes, sorry, my bad, cloud native project that serves as a CSI along with your Ceph. Okay. So this is the Rook architecture, and this particular orange logo is for Ceph. So Rook and Ceph works together to maintain this CSI driver. I won't go inside it. I'm just giving you an insight, like I'm just giving you a rough insight about how it works and what is it actually. Okay. And configurations, I think it can be too much config maps. I don't think that it will be a good topic to start with for beginners, so I'll just skip it. Okay. So, okay, I'll just talk about two types of scaling. One is horizontal scaling and one is vertical scaling. So, when we actually talk about horizontal scaling, we talk about increasing the machines. Okay. And whenever we are talking about virtual scaling, we talk about the increase of the capabilities of that particular service on the same machine, right? So if you check it, what it does and how it works, you'll get to know in detail, right? And what I'll do is, you have had enough idea about Kubernetes object, container technology, and everything. Now I'll move towards a bit of CI/CD. So you already have an idea about CI/CD because you got a demo, hands-on demo from the previous lecture. So what CI/CD does is that it makes your life easy as a tester or as a developer when you are trying to develop and deploy your own applications for production, right? So there can be two types. Okay, one is pull based and what one is push based. So how is it different from each other? So if you go inside the GitOps section, you will get this difference, pull based and push based difference. And to get it more clearer, you have a blog attached to it. You can read this blog. This blog is really very good. This very blog actually cleared my conception regarding pull and push based approach. So you should give it a try. In a nutshell, what pull based and push based has a sleek difference. That is, when we are talking about push based, uh, it is actually triggered by the Git pushes and anything that is changed by human interactions. Whenever suppose you are actually trying to commit a change on your code base and you commit it, and now the GitHub code base is updated, then the particular GitOps mechanism is triggered. Then it is known as push based. But whenever pull based come into the picture, the cluster actually tries to get information by itself. Okay, this is what it says, that pull based model relies on an agent within the infrastructure that continuously sees if there's any change or not. Whenever it gets a change, it just pulls. Whenever it pulls from the repository, it again delivers. Right. So this is how push and pull based mechanism works. And Argo CD, for example, is totally a pull based approach technique. Okay, this is also a CNCF project, and this is also a part of your CNCF landscape. Everything which I was talking about since like hours are all part of CNCF landscape. And at the very end, I'll just go inside the CNCF landscape so that you can get a better understanding why I'm talking about this. So you will get an understanding on how these tools look. Because if I directly get on the CNCF landscape, it may look overwhelming, right? So why Kubernetes is ideal for GitOps? And you already know the answer. Kubernetes declarative nature and comprehensive API makes it excellent fit for GitOps, right? It inherently supports the GitOps model by applying desired states defined in Git to the actual infrastructure, mirroring the pull-based approach within its operational design. I talked about the pull-based, right, which is being followed by Argo CD, right? And if you want to know more about GitOps, you can actually use this particular course, which is free. It's served by the Linux Foundation itself, so it's the best material you can find on internet, right? So cloud native observability. Now I'll slowly touch on the observability part. Why it's even important. By the way, till now, folks have understood everything, right? Is there any questions you have till now? Anything that is bugging you, please let me know, please, guys. And if I'm getting too fast or if I'm getting boring, please let me know as well. कुछ चुटकुले भी सुना दूंगा. Nothing? Can't see any responses from here. Hello, guys there? Am I disconnected or what? Till now, whatever I have told, am I making sense? Everything is clear to you guys? All right, I'll consider it as a yes. So let's talk about cloud native observability. So why is this important? Whenever we are talking about complex microservice structures, we often get to see that it's very, very problematic to find problems in a network. Okay. Whenever we talk about microservices, we talk about its pros. But there's one con to this microservice architecture, that is to monitor or to get to the point where errors are happening. It's a very, very tedious job for the DevOps and SRE engineers. So how we do that? To get hold of the error or to know where the problem is exactly lying, we use tools which are responsible for observability. And by observability, we mean metrics, logs, and traces. So what is metrics? Metrics is a numerical data, okay, that actually represents various aspects of a system at the particular time. Like it will actually give you the values in numerical sense so that you get to know how the system is performing, it if it's healthy, if it's dead, anything, or how it's performing. If even if it's performing it at its best, you get to know. Logs is very it's a very buzzword. You have already heard about logs. Logs is something that is unchangeable history of patterns that has been made by a computer system, by a user on a specific architecture on anywhere. Whenever we talk about time-stamped records of events happening in your computer, it's logs, right? And traces. Traces are like long-term data which comes up with API calls. Whenever we talk about traces, I actually mean by this. If I just show you real quick how traces actually look like, I think this will be the best scenario. Yeah, I think I'm doing good. Okay. Whenever you switch to the networks tab, and I reload this, have you seen this particular slide? This one, this waterfall, this particular thing over here. Have you seen this? This is nothing but traces. This is how traces work. From start till the ending, it saves the band of data so that you get to know how an end-to-end request flow is made. See, we can actually get the data from here. Like if we check how much we had to wait for the response, how much content is being downloaded, how much time we had to queue for it, everything. This is a part of tracing. Okay, this is just an example of how traces works. Real world example. Okay. Now I think you got to know how metrics, logs, and traces are different. Now, if I talk about these, okay, these are all collectively known as telemetry. Telemetry from its Greek root meaning remote measuring. Okay, now I'll just slowly move towards logging. Logging, as you know, that we are using tools which are actually responsible for logging itself, and that is Prometheus. Prometheus is a great tool to actually log everything in style, right? So I'll get to the Prometheus tool if you have time. I think we are already running out of time, so I won't get more inside this. But if you see the website itself, it says that from metrics to insights. Like this is what it does. Okay. Prometheus is a great tool which has become a part of CNCF in 2016, and it's now like the best tool out there. Okay. So there are some metrics like type, that is counter, gauge, histogram, and summary. Okay, now you can actually explore it more. And if you these are like raw data which is being provided by Prometheus. But if you want to get GUI, or if you want to get some graphs out of it, then Grafana will come into the picture. Grafana uses the same data provided by Prometheus to show you the real time stuffs. It may look very nice, okay, and it is very nice. It's very attractive to work upon. So give it a try. Like install Prometheus and Grafana, and get started with such dashboards. This looks really intriguing for me as well till now. So yeah. So at the end, what is the purpose of doing this? Cost management. Whenever we are seeing where the resources are going, how it's uh, performing, we can directly minimize costs, and also we can also make sure that we are the least error prone, right? So this was basically it, and I will now, after this thing is done, now I'll move towards the main stuff, that is the CNCF landscape. This is CNCF landscape for you guys. Here we go. Now you may tell me that why I was not coming to this in the first place. So this can get a bit tricky for beginners to understand. There are multiple tools. You can see like there are huge number of tools involved in this CNCF landscape. Everyone here is a part of CNCF. Okay. So the CNCF inventory is huge, and the possibilities are endless. Now, if I talk about big tools, which I mentioned about, this one, Argo CD, it's under continuous integration and delivery. Now it will make more sense. If I would have, like, if I uh, mentioned this page in the very first place, it would have been more like difficult to get. But now it's a bit easier for you. Like if we talk about CI/CD, you now know that Argo CD is associated to it. That's why Argo CD is here. Flux is there. Okay, Flux was also mentioned in that doc. Whenever we are trying to uh, make application definitions and image builds, Helm is there. Helm is a very popular tool. Okay, now whenever we are trying to orchestrating something, Kubernetes, everything is around Kubernetes only, but still they have mentioned Kubernetes separately. So you already know about Kubernetes. Then I'll mention quickly about Rook. This is the storage part which I was talking about. Rook is there. Yep. Then we have Cilium as a network, CNI, but I didn't mention about this much cause it is a bit tricky. Then, then. Okay, I think, okay, this one, Prometheus. I talked about this, right? Prometheus is there. I just talked about this few minutes back. So now it's a bit easy for you. That see, it's under observability portion. Now it's making sense, right? Is it making sense, guys? Why why this why this is being like separated from each other? Why the tools are listed down like this grids, and why I was not showing it to you in the first place? Is it making sense? Now you can actually explore more on this. It's up to you guys. You can explore more. Uh, you can click on individual applications, individual projects, and you can actually explore more on this topic. But now you guys can get an idea why I was talking about everything in the like upfront, not directly getting into the Kubernetes CNCF landscape. This was the sole reason for that, because it may get clumsy for everyone. In fact, it still is clumsy for me. Okay. Jenkins. Whenever you had a session on Jenkins as well, when it was when CI/CD was being explained to you with a hands-on, Jenkins was into the picture. See, like everything is here. Everything you talk about in CNCF or cloud native is over here. So make sure that you check it out nicely. You can see like some tools from Netflix over here as well. Okay. There are multiple tools, and also I would just quickly mention a fun note that anything over here, like you can see many projects, many logos. You can get multiple stickers from me in the offline session, which can be very much similar to these logos, because I'm a CNCF ambassador. So I have the stickers for you guys. With that being said, I just want to announce that we will be having the first ever session of 2024 in-person event on 27th of April at the Government College of Ceramic Technology. And I invite you everyone over there, all the Kate Smashers, enthusiasts, all the members of Cloud Native India are invited over there so that you can enjoy and we can meet in person and share our ideas over there. Right. I would request the team to share the registration link so that they can join there. All right. So with that being said, any questions, anything, please let me know. Otherwise, I think we are done from the presentations perspective. Do kindly join the waitlist, folks, so that you can get the ticket for yourself and get the chance to meet everyone from the team and connect with like-minded folks, right? So someone may ask, like, why offline events? What is the purpose of offline event, right? So the first thing is that you need to understand nowadays connection is very important. Making connections around you to build the network is very important. So you have the network. After that, you connect with those people who are actually interested in your domain. So you connect with those people, like apart from the people you have networked previously. So you get the knowledge from them, right? So you get network, you get knowledge, and if you get some swag, then where's the wrong? Like, what's wrong with that? You get some free goodies from art, and that's the best thing, right? So yeah, so there are many reasons to join us at the offline event, and the best part, it's free. It's totally free for everyone, but it's definitely on demand basis. So please grab your tickets fast so that you can be a part of our event CubeCraft. And this will also serve as the ending ceremony for Kate Smashers in person. So I'll request everyone who have attended Kate Smashers till the end and also the quiz winners till now to join us at CubeCraft on 27th of April. That's a humble request from my side. All right. I believe that everyone over here will register for that. And with that being said, I would request the organizing team to start with the quiz. And if you have any questions or doubts, please drop it in the chat section. Over to you, organizing team.
Thank you, Ronit Bhaiya. It was amazing session. I hope everyone enjoyed it. I need to see in the chat box. Okay, so now we are moving on with quiz. Sanyukta Di, please share the screen. Yeah. Everyone do join the quiz. We'll be starting soon. Okay, great.
I want five more folks to participate over here. Can we have five more people? Yes, 20.
Count reach 20.
Let's
Good.
get to 25. And you all know what's waiting after this quiz. Till now, like this is the seventh Kate Smashers session. We had six previous sessions, and this will be the final one for the Kate Smashers. And in every quiz, we had like in every session we had a quiz, and after the quiz, winners were being declared for the lead from the leaders board, and they know that they will receive some special goodies from our side. So, yep, come up and participate in the quiz. Who knows? You can be the winner as well.
Four more people. 22. अरे इस बार निमेश भैया का फैन अंकना दी का फैन नहीं आया.
No, 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 not really. Today I have captured the fandom. Just kidding, guys.
Okay. One more people. 24
One,
we are.
one more. We need one more participation, and we can start it off. Okay, let's start it. Let's get started. Ready? One, two, three, and let's go.
What is the core principle of cloud native development? 55%. Great. Designing applications. ओके. रोनित दा का फैन हूँ. क्या बात है. What is the benefits of using concrete application in a cloud native environment? कौन बताएगा आंसर? 62. Impressive. अरे वाह. What is the role of infrastructure as code IAC in cloud native development?
Nice.
What is the key characters of microservice architecture in a cloud native system?
Loosely coupled systems.
5. What is the purpose of a service mesh in a cloud native environment?
This is a bit hard question, but let's see. Okay, 58%. Nice.
What is the difference between continuous integration and continuous delivery in a cloud native pipeline? Option A, 38%.
CI tests and CD delivers.
What is the advantage of using API gateway in a cloud native architecture?
ऑल ऑफ द अबव देख के बस टिक कर दिया सभी ने. ऑप्शंस पढ़ भी लिया करो मैडम.
What is the concept of declarative versus imperative approach in the cloud native development? इसमें तो all of the above नहीं है. 23. Tough one. Good. What are some key constraints for implementing observability in a cloud native system? All of the above. Ronit Da का fan हूँ, rocking. How does cloud native development benefits from infrastructure automation tools in Kubernetes? रुको, what is the role of serviceless functions in a cloud native ecosystem? Option A. रोनित दा का फैन आइडेंटिटी रिवील चाहिए मेरे को लास्ट में.
I know who is it.
Oh, what are some security concerns associated with cloud native developments?
It's the same person who has made the quiz.
Oh, and the answer is option D. How does GitHub promote a collaborative workflow for cloud native development?
ये मैंने लास्ट में बोला था. How it works.
कितने लोगों का सही है? 26%.
I told how it enables declarative management.
Okay. And how can cloud native applications leverage
Leverage
even
event-driven architecture for efficient communication.
application? Okay, 21%.
I think this is the last question for today's quiz and Kate smashes overall as well. Let's go.
Done. What are some key strategies for achieving high ability in cloud native developments? यहाँ पे भी all of the above है. What will be the answer? Okay, 90. Oh
No,
ho,
this was a trap. This was
Googie.
a trap.
Nice one. Only 4%. रोनित भैया, रोनित दा का फैन हूँ. ओके
It is Nimesh for sure.
भैया, हाँ.
Okay, I think let's get to the leaderboards. And Aditya,
E.
Aditya, you there? Hello? Okay, he's
Yes,
here.
I'm there.
Yes. No, are you the first time winner or you won some previous quiz?
First time winner.
Okay, so you
Congrats.
congrats, you are the first position. You have got the first position in our last quiz session. Who is Sam? Oh no, who is it? I think it's Anyukta. Anyways, we can skip it. I don't know who is Ami Kate's message on me, Poila Vaishak. It's not me, okay. Okay.
तो स्वैग किसको दें भैया?
Who is Abhinav?
Yes,
Abhinav, you got the second position because the rest of the folks
thank
are
you.
okay. Poila Vaishak is Spandan. Who is Spandan? Is Spandan over here? Okay. I believe you could have like mentioned your own name. Anyways, can you just show me where Spandan lies. Poila Boishak is in second position, right? Okay, so Spandan, you got the second position. Nimesh, please note down the names. The first position belongs to Aditya, second position belongs to Spandan, and the third position belongs to just get down. I think it's Avinav. Yeah, Avinav. Abhinav. So here are the three quiz winners for the last and final session of Kate Smashers. Congratulations.
Thanks, guys.
You'll get a
Thank you,
small
Bhaiya.
token of love from our side. And you all are cordially invited to our offline event that is happening on 27th of April at Government Technology Ceramic College. And I believe everyone over here will be present over there. So yeah, that's pretty much about it from my side. It was great discussing with you all. And I would just request one thing at the end, that is to join Cloud Native Hubli. And how you can join Cloud Native Hubli, I'll just give you the link and I'll show you how you can join Cloud Native Hubli as well. So here's the link. This is the link for the Discord server, and the link I mentioned is for the official chapter uh, one. And yes, everyone will join the wait list only. We will release the tickets dhire dhire, and you can actually click on the join option. The link I mentioned, you can click on it, and you can actually click on the join option. After you are joined, you will need a LFX ID for this. After you have the LFX account, then you can join our chapter, and you will get the further notifications from our side over email. So yeah, this is how you are successfully our chapter member. Congrats. Right? It was that simple. Folks who have already joined, thank you. Folks who are joining right now, please do join ASAP because we are planning like exciting things for the future events. So yeah.
Okay.
And everyone is requested to join our Discord server as well, and specifically the quiz winners, because we have to communicate with you over Discord so that we can reach you and get your like
Swags.
yeah. Okay. Aditya, Spandan, Abhinav, congratulations again. Please join the Discord and communicate with our organizing team. Nimesh will be helping you with the rest. All right. KCD
Thank
Kolkata. Good question. KCD Kolkata. I am requesting the CNCF team for KCD Kolkata. Okay, we are still in talks, but let's see. I am also very like excited to have KCD in Kolkata because we have KCD Pune, we have KCD Mumbai and stuff, Bangalore itself, but never Kolkata. But I really want to organize a KCD Kolkata. Let's hope for the best. I'll try my best for that. Promise.
Anyone has any questions?
If
Great.
not, then
We
I
can call
think
it a day.
yes. So this was your chapter lead, Ronit Banerjee, and I actually forgot to like introduce myself in case you are new to me. So I'm Ronit. I'm CTO and co-founder of my self-bootstrap startup Project X.Cloud, and currently I'm a CNCF ambassador. And apart from that, I am a Google Summer of Code mentor this year, and I was a mentee in the previous year at DPpedia organization. So yeah, I'm in this ecosystem, open source ecosystem since 2 plus years, I believe. And I'm an open source contributor at Linux Foundation and CNC. So that's pretty much about myself. That was not important, but still, I hope that yeah, it was enough for my
introduction. Right. All right. Again, once again, thanks for joining. Shubho Navabarsha to everyone. Hope your year gets better and better as we proceed with cloud native tools and technologies. Good night, everyone. Thank you so much. Signing off.
Good night, folks. Stay tuned for more updates.